All right, today we're going to be doing lesson 11.1 and 11.2. But first we're going to go over 11.1, which is solving proportions. Now, what a proportion is, and you may have seen these before, is two fractions that are equal to one another. So a good example of a proportion could be something like 1/2 is equal to 3/6. Now, I know 3/6 is not identical to 1/2, but if I were to reduce 3/6, I would get 1/2. So they're equivalent to the same amount. Now, with what we're going to be doing today is we're going to be working on finding proportions when there is something missing, like right here in this proportion. I can always solve a proportion that has a numerator or a denominator missing because I know what it's going to be equivalent to. So in this first problem here, we're going to solve these proportions. Solve what is missing in these proportions. And the way that we're going to do that is called the cross product property. Or another word for that would be cross multiplication. Okay? The book teaches another way, which is called the reciprocal property, but we're not going to do that. We're only going to learn cross multiplication. I think it's the easiest way to do it. All right? When you are doing cross multiplication, this is exactly what you do. You are going to take what is across from each other or diagonal and multiply that. So in this case, I have 5 times x, which is going to be 5x. Now, what is very important about a proportion that you cannot forget about is this equal sign right there. That's what makes it a proportion because it's equivalent to one another. So what you're going to do is once I multiply what's diagonal from each other, I'm going to put the equal sign there. Then I'm going to multiply the other diagonal. 2 times 60 is 120. Then all I've got to do now is solve for x. So I divide by 5 on both sides, and I get x is equal to 24. 24. Okay? So let's do the next one. Cross multiply 2 times w, which is 2w. And then I have to write that equal sign. Then I'm going to multiply 3 times 3, which is 9. Divide by 2. And I get w equals 4.5. Or I could leave that as w equals 9/2. Either way would be a correct answer. Now, if you notice, we always started off by multiplying, like if I had, go back to this. We always multiply this side first. But it does not matter which one of these you multiply first. I could do x times 2 first and then do equals 6, or I could do 6 equals 2x. Either way is just fine. All right? So let's go to the next slide. We're also going to be solving these equations, all right, these proportions using cross multiplication. Now this time I've got a whole lot more variables than I did on the last time. That's fine. We can still solve them for what x or y or whatever the variable is. Okay? So first thing that I'm going to do is I'm going to cross multiply. X times x plus 1. Now listen carefully. What you've got to do is you've got to multiply this x by everything over here. So it's going to be x times x, which is x squared, and then 1 times x, which is 1x. Don't forget to multiply that x by everything. It's just like distributive property. Then I put my equal sign, and I do 3 times 4, which is 12. Now, in order to solve a problem like this, because I've got an x squared and an x, so I know I cannot divide by 1 and get x by itself because I've got 2 separate x's and they're not like terms, so I can't combine them. So what I want to do is I want to get one side equal to 0, and then I'm going to be able to factor this problem. So if I get one side equal to 0, I'm going to subtract 12. Move it over to this side, and then I have x squared plus 1x minus 12 equals 0. and I can factor this problem right now. I need to list the factors of 12. 1 times 12, 2 times 6, and 3 times 4. And I need to figure out which ones are going to subtract to give me 1. I realize that's 3 and 4. So then I start out writing my problem. 2 parentheses. I've got to keep that equals 0 because I can't drop it. Put x's in the front, a 3 and a 4. And I know since this 1 right here is positive that my largest term has to get the plus sign. So 4 is going to get the plus, 3 is going to get the negative. Now I can just solve these like we did on our test. So I'm going to break it into 2 problems. X minus 3 equals 0 and x plus 4 equals 0. So I add 3 to both sides and I get x equals 3. I subtract 4 from each side and I get x equals negative 4. These are my final answers here, okay? So whenever you have more than one x, like an x squared and an x, or maybe it's an x to the 3rd power and an x squared, something like that, that they're not like terms, I need to set one side equal to 0 and see if I can factor it. All right, let's try this second problem here. Now I'm going to multiply negative 5 times x plus 3. So negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Then I'm going to write my equal sign. Now on this next cross multiplication here, I have x minus 3 times x plus 5. Who can raise your hand and tell me what am I going to do to multiply these? Henry?
You're going to multiply the 2 x's and the 2 numbers without variables?
No. Ryan? FOIL. Very good. Remember when we learned FOIL? It's going to look just like this. X plus 5 times x minus 3. Remember, I always want to multiply by everything. So I've got to do FOIL. Okay? So I do first, well, I'm going to rewrite this side first. First, which is x squared. Outer, negative 3x. Inner, 5x. And last, negative 15. I want to go ahead and combine like terms over on this side. So I'm going to have positive 2x minus 15. Now, same exact scenario here. I have an x squared and an x. So, I can't just solve for x automatically because they're not like terms. I can't combine them. So, I've got to get one side equal to 0. So, what I can do is I can add 15 to both sides. Come over here, add it with its like term. What's going to happen when I add 15 to negative 15? It cancels out. Basically, that equals 0. So I don't even need to write it. Now, what should I do to move this negative 5x over? Tristan? Add 5x. Very good. So I add 5x here. I come over to its like term, add 5x, and I get 0 equals x squared plus 7x. Now, I look at this and I go, okay, I cannot factor this because I don't have a c. Anytime you don't have a c, you cannot factor a problem. So I ask myself, okay, maybe it's the difference of 2 squares because I have 2 terms. Okay, let's look at that. First of all, the word difference. Is this a difference problem? No, because it's not minus, so can't do that. What's the only type of thing that we learned yesterday that I could do here? Look at both of these terms. What do they have in common? X. So I can take out a greatest common factor. Okay, I can't do the square root because I could do the square root of this, but then what's the square root of 7x? 7x. There is no such square root because it's not squared. Okay, so I just want to take out the greatest common factor, which is x. Now what's in parentheses is going to become x plus 7. Now this looks like a problem I can solve. Remember, we had these on your test too. So I could write x equals 0. That's one of my answers. And now I can write x plus 7 equals 0. Subtract 7 and get x equals negative 7.
How'd you get x equals 0?
Because this x right here on the outside has to be set equal to 0 as well.
So you automatically have 1, 0.
Mm-hmm. Okay. Now let's do this last problem here. And this last problem is a little different, so I want to make sure that you're paying attention to this. All right, we start off and we cross multiply just like we would always do. 2 times y squared is 2y squared. 2 times negative 9 is negative 18. Put my equal sign. Then again, I'm going to have to FOIL here. So y times y is y squared. Y times negative 3 is negative 3y. Positive 3 times y is 3y. And last, positive 3 times negative 3 is negative 9. Okay, I need to combine these like terms. What's going to happen when I combine negative 3 and positive 3? Cancels out, so it's going to equal 0. So now I've got 2y squared minus 18 equals y squared minus 9. Okay, I realize, yes, I have y's left. Are they like terms? Yes, they are. So I can put the y's on one side, and I could put the numbers on the other and solve for y. So let's do that. I'm going to subtract 1y here, 1y squared, and I'm going to get 1y squared, or I can just write y squared, which is what I'm going to do. Equals, then I've got, oh, I'm sorry, not equals yet. Negative 18 equals negative 9. Then I want to add 18 to both sides. And I get y squared equals 9. What can I do to solve for y here? Square root. Very good. Now I can take the square root. Square root of 9. So I get y is equal to positive and negative 3. So I'm not sure exactly what y is equal to, because I know it can be equal to positive 3, but it can also be equal to negative 3. So this is where this problem is different. Now I've got to check my answers, because one of these may not be a solution. So I've got to go back to my original problem, plug each of these numbers in, and find out either yes, it's going to be a solution, or no, it's not. It's a very simple process. It does not take very long. So this is exactly what you do.
If you added 18, how did you get 9?
Because it was a negative 9 over on the other side. Okay? All right, so I'm going to plug in a positive 3 first. I'm going to look at my original problem, and I have y squared, so I'm going to plug in 3 squared minus 9 over 3 plus 3, and it equals 3 minus 3 over 2. All right, let's check it out. 3 squared is 9. 9 minus 9 is 0. Over 3 plus 3 is 6. 3 minus 3 is 0 over 2. Any fraction with a numerator of 0 equals 0. So 0 equals 0. So is y equals positive 3 a solution? Yes, it is. All right, so I know that this is one of my answers. Now I've got to check negative 3 and see if that's going to be a solution. All right, so I do the exact same thing. Negative 3 squared minus 9 over negative 3 plus 3 equals negative 3 minus 3 over 2. Negative 3 squared is 9. 9 minus 9 is 0. Over negative 3 plus 3 is 0. Negative 3 minus 3 is negative 6 over 2. So now I've got 0 equals negative 3. Is that a solution?
Isn't it undefined?
No, it's not. It is going to be 0, okay? Anyways, the negative 3 is not going to be a solution. So therefore, my only answer is y equals positive 3. I cannot box this in and say it's my answer, because it is not true. Y is not equal to positive and negative 3. That's why you have to check problems like this. Now, the other ones we didn't have to check because I got an exact answer. I got that y was equal to 4 or y was equal to 2. I knew what x or y was equal to. But on this one, I did not know exactly what it was equal to, so I had to check it out. Okay? All right, we're going to move on now to 11.